Good morning, everybody. Look, we've gone through last week some things on locating the house, easements, things like that. We've gotten through grading, we've gotten through all the stuff leading up to building the house. Now I want to start getting into actually starting the process of putting the house in the ground, okay? There's a lot of information here, okay? What you see here is not going to get all taken care of today, but I wanted to give you all the package, and please hold on to the packages because you're going to need them in the weeks coming, okay? The first thing I want to talk about is what happens before the house goes in the ground, okay? What you have to understand is all the utilities and all the draining and all of everything that goes under the house has to be completely finalized, completely, before you start, okay? You've got electrical service, you've got water lines, you've got drain lines, and you've got things you might not have thought about, like low voltage lines leading out of the house for exterior lights, security, things like that. All that has to be finalized before you start because you can't put the pipes under the ground unless you're sure where they go, okay? The final mechanical room layout's a big one. Usually the layout you get with the plans doesn't work, okay? Because it's very generic, like we always talk about. It's a generic plan. They put so many panels, they put so many things. On the job I'm working on now, the MDP that's drawn at 3 foot, when we finally got the submittal, was 6 feet wide. That changes where it goes in the room. Also, pipes don't always wind up in a wall. When you're doing the MDP, for example, that depending on the depth of it, it's 6 inches off a wall or 10 inches off a wall because it comes from below. So having all the specs, having all the plans, working all these things out ahead of time has to be done before you put a shovel in the ground. Because afterwards, the only way to put anything in is to chop the slab up. You don't want to get into that. Okay? When we did the last project, the septic was on the south side of the house. The plans had us putting the drain, leaving the house on the north side, which would have meant going all the way around the house to the septic with the drain. With the required pitch, it wouldn't have made it. So sitting down with the plumber, sitting down with the electrician, meeting with the MEP engineer to make sure all these things are laid out and finalized is really important. And it takes a lot of time. And it's something that you can't rush through. It's almost as important as getting the shell up. Okay? Okay. So we gotta, before we do anything else now, we gotta talk about how the house is going to be built. Okay? The first thing is setting the grades. Now the grades are set, usually you meet with the shell contractor to determine what the grade you're gonna have laid out to start with. Okay? That's going to change depending on the type of foundation you're putting in. Okay? There are multiple types. If you look in here, I'll give you some examples. We've gone through some helical and auger pile arrangements on the last time we went around. And all of these foundation types are based on the soil report. We've talked about the soil report and the soil conditions in the last time. Based on the soil conditions, there's compact density that can be reached. In other words, when they compress the soil, is it going to stay firm or is it going to continue to settle? If it's going to stay firm and the soils are good, you can put a footing in. This is pretty much a footing detail, okay? The concept of this is simple. Anybody who's ever walked on the beach knows that if you walk on your foot, you don't sink into the ground. But if you took your finger and you push straight down, you'd go directly into the soil, right? The footer spreads the weight over an area, okay? When something comes straight down and is pushed like this, that's a point load because it's hitting one point. So when you're building a house, the engineer has to look at how is the weight of what you're building distributed. If it's a solid wall, the weight's distributed over the whole wall. If you've got 20-foot sections of windows and there's a steel column between each, it means all the weight from above is pushing on that steel column. So when the engineer looks at this, he's got to decide, I'm going to look at the soil conditions, I'm going to look at where the weights apply and how much weight that is, and how I'm going to achieve enough to get in there, okay? So There's ways this is done. If he's doing a footing condition, the grade is simple because he's going to meet the grade 4 inches below the slab, he's going to go to the footer. If he's going to go to a auger pile, as he digs, soil's coming out. So now he's got to go to a lower elevation so that he can account for the soil that comes out of the pile, bringing it up. All these things are reviewed and determined with the shell contractor before you start. For example, we're doing auger piles on the project I'm on now. We are staying 2 feet below the finished height. That 2 feet will account for the soils and the spillage coming out when we do the piles, and we'll bring it up to the grade we're anticipating. It's pretty sure something we've learned by experience in doing past jobs. Okay? Okay, so when you start, the surveyor comes out and he locates all the piles that are going to go in. This drawing, if you guys can see it, is a drawing given to us by the surveyor. What he does is he comes out and he flags where every pile is going to go. He puts a stake in it, the stake has a number, and there's a flag on it. When the piles go in, the engineer has a copy of this drawing that's monitoring the project. He knows we're looking at pile 438 or 439 or whatever it is. He's watching the pile be installed. Okay? So the surveyor will mark this. There's things you have to know about all these things, and we'll get into that later on more and more. This is not something you're going to pick up. Right now we're doing an overview. We'll get into specifics later. Okay? So the first thing that's going to happen is after you've reached grade, they're going to come out and they're going to mark the piles. After that's done, we'll arrange to have the pile company come in, whether it be helicals, augers, driven piles, whatever they are. And they'll come and they'll start the installation. An engineer will be monitoring the installation. He's going to give us a report at the end, an approval that these piles were put in and monitored and are in correctly. The inspector who comes to look at this later, when he looks at the forms and everything else, is going to ask for a copy of that inspection report. So it's important. The inspector, for example, will say either it has gone into depth, like when we talked last week and we looked at the soil report, the engineer working for Nutting in this case will say the pile has to be 40 feet long to reach good soil. The engineer will then come, watch it go down 40 feet, and he'll either sign off that, yes, it was put into 40 feet, he'll check that one off, or he'll say it hits refusal. Hitting refusal means it goes down to a point where it hits stable ground, whether it be a rock, a different soil condition, whatever, and he's acknowledging that at that depth, it's going to be structurally sound. Okay, so the two options are either going to be reach depth or refusal. When that's done, we have to make sure we get a copy of the engineer's report and a copy of this drawing, which correlates to that report, which shows where everything is. Everybody kind of understand that? Okay. At that point, you have all the forms in the ground. The shell contractor is going to level everything out. He's going to get everything straight. At that point, you're going to call the surveyor back. The surveyor is then going to locate the walls of the building. And he'll locate them not on the wall, but 1 foot over for the wall, or 2 feet, whatever it is that we ask for. If he puts it right on the wall, when you excavate, you're going to lose all your pins. Okay? So he'll go a distance off, and we will put on what's called a banter board. Okay, you guys have seen this. They look like sawhorses on the corners of the building. Okay? He'll mark. They'll run a string across the banter board to the end of the buildings. As they excavate and as they form, they'll go 1 foot in from that mark, or 2 feet, or whatever you've told them to lay it out to. That gives them a clean line that you can maintain without losing it because you're digging up the line. Okay? Now, from that, they will rail it. Railing is simply putting a form around the perimeter of this house. In other words, when we pour the concrete, that's the outside form. They'll come in, they'll put the rail up based on these banter boards and the surveyor's marks. We may ask him also to verify the elevation at that point. At that point, you've built a frame around the entire house. Okay? Have the surveyor come back and do a form board survey. He will then come in. He'll mark what you actually put in. And he'll locate the corners that you have actually installed to verify that you have met the right dimensions, that you've got the 1 foot right. You have to have the form board survey before you can continue. If you've made a mistake at this point, you can correct it. If you pour the slab and you're off by 6 inches, you can't correct it. And a lot of the dimensions you may be taking inward. For example, when the plumber comes and he's going to set a drain for a toilet underground, he's probably going to measure from that form board back to put that in its right location. If that form board is not in the right location, then that toilet's going to be in the wrong location. And whatever they use to measure is going to be in the wrong location. Traditionally, what we do is as the form board is installed, we'll mark the walls on the form board. That way, just like the benchmark on the wall, everybody's working off the same lines. The electrician is marking his walls, his piping based on that location. The plumber is holding his lines based on that location. Everything we do is a coordination between all the trades. It's not just you putting your frame up and them figuring it out. Everybody's got to be looking at the same lines. Everybody's got to be looking at the same thing, okay? Now, at this point, you've got your frame up, okay? Depending on how this is designed, they'll excavate and they'll either do a form board, which is what you see here, okay, where you're actually putting a form up to pour all the grade beams, okay? Or, I had it here somewhere, there's that photo. You got it. No, that one, yeah, give me that one. This is an earth form, okay? Basically what you're doing is you're forming the beam using the earth as the form. Now, why do you do this? In many cases, you're going to pour in one monolithic pour the form, the grade beam and the slab. You don't want to capture these forms under the slab. So you do that. You form it. When you're done, the rebar will go over the top. It'll all work out. So at this point, you've railed it, right? You've excavated for your forms. Now, plumbers, electricians, low voltage contractors, whoever it may be, has to come in and run all their rough. Okay, and again, it means you have to coordinate early for storm drains. Where's the pipe coming out for the gutters? How is the pipe getting to the septic? And at what elevation is it coming out of the house? Because you have to figure when you come out of the house, the bottom of the slab or the grade beam is at whatever dimension it is. What's the pitch from there to the septic tank? Can you get to the exfiltration fields we talked about last time? If the exfiltration field is here, at what depth do you have to come out of the house because you can't go uphill to the exfiltration field? This is why it's important to have your meetings ahead of time. All these things have to be worked out so that when you actually have them run their pipe, they're put not only in the right place, but at the right elevation. Okay? Okay, so at this point, let's assume you have it railed, you've had it surveyed, you've had the elevation verified, you've dug for your footers or your grade beams or whatever it is in this case. Now, the shell contractor is now going to do his final grade. You're going to have all the piping inspected, everything, the electrical, the plumbing, everything's going to be inspected. And the plumber is going to put a stainless steel strap. The electrician is going to put a stainless steel strap on his pipes. And it's going to come up and it's going to weave into the beam. This soil at the beach is not necessarily always going to stay there. If there's washout under the house, if something happens, you don't want these pipes to lose pitch. So the inspectors now want stainless steel straps that go into the concrete. So when it's poured, it holds the pipe at the elevation you've put it at. We did a job at one of the town offices, and we dug out the bathroom. Jody, remember when we dug out the bathroom? And when we opened the floor under the house, under the building had sunk 2 feet. The pipe went down with it, and there was a 6-inch gap between the bottom of the toilet and the pipe coming up because everything sank. Okay, the strapping and tying it into the slab stops that from even happening. Okay, so at this point you've got your inspections from all your subs. The grade has been set. You're going to have the shell contractor come back, hit final grade, make sure that nothing's been moved. They're going to spray it for termites. This is a local requirement, and when you do your final CO inspection at the end of the job, they're going to ask for the certificate that verifies you have sprayed the soil for underground termites. Okay? It may seem odd, but it's what's required, and it cannot be missed. Okay? At that point, you're done with that. A plastic vapor barrier, visqueen, goes over the entire slab before you pour. You do not want moisture emanating through the slab later. And so we put that over the whole thing. We have the whole thing inspected, the rebar, both on the slab, in the grade beam, everywhere. Now, I use the term rebar. A lot of you know what rebar is, a lot of you don't, okay? When you get the drawing, and we'll go into this more, you'll see some more backup on this. This is rebar, okay? It's reinforcement bar, okay? Comes straight steel or galvanized, okay? And this will tell you what number it is. It's based on the size, okay? For example, number 3 rebar is 3/8 of an inch. Number 4 rebar is 1/2 an inch. When you get a drawing like this, it will tell you this is what rebar this is. Like, for example, this drawing says this is number 5, okay? When you get number 5, you'll know number 5 is 5/8 of an inch thick. The installer will take number 5 and he'll run it with this. There is a stirrup which wraps around and forms the cage. You see this cage? See this cage here? Okay, this is drawn on a diagram just like this. It'll say what the upper, what the lower, and what size. Okay, this is a stirrup. So he'll run the rebar through, he'll strap it, he'll basically emulate whatever is on the structural drawing. Okay. Once he's done all that, he has the rebar, and on the drawing, which I'll go through the next lesson a little bit more, it will give you a graph, not a graph, a chart, which will tell you what the rebar is in different locations, okay? It'll tell you what the beam and what the column looks like. There'll be a beam schedule, there'll be a column schedule, and it'll tell you what's required in each one. In every case, you're going to follow that chart, and you're going to use the appropriate rebar and strap it. Now, the inspector is going to come out. He's going to look at the structural drawing. He's going to say, show me the detail for this footer or this beam. He'll look at it. He'll look to make sure it's what's on the drawing, and he'll go through every beam. He should go through every beam. He'll also show what's run across the slab. In some cases, it's just rebar. Some cases, there's a mesh that he wants across. It all depends on what the engineer of record has designed. Okay, everybody got that? Okay, it's a lot of information, but it's basically a puzzle that you have all the directions to on the engineering drawing. When you get this drawing, you don't just get it and go to work. You get this drawing and you review it. You make sure you understand it. You make sure that what's on the drawing actually makes sense. Okay? We've talked in the past about how sometimes drawings aren't right. Okay? Because the person doing the drawing isn't the person looking at the structural, isn't the person looking at the plumbing, isn't the person looking at the electrical. All these things are a puzzle. Phase 1 of this puzzle is the slab. Okay? From this point, we'll get into walls, we'll get into columns, we'll get into point loads, we'll get into things like embeds. Okay? all these things are used throughout the house for structure. The job we're doing now, Devin went through the window schedule that we got and found things. I went through the window schedule and found that the openings don't match the window schedule. So we went back to the architect. All those things have to be resolved before you put the slab in, because any modifications that you make, you might have to make as the slab is going in. Okay? The history of the job always starts with finally reviewing the drawings in their entirety. Okay, just like all the things we've talked about in the past. Okay, shop drawings on the windows can be modified if the drawings are correct and you know they're right. We're on our third revision of shop drawings for the windows now. Okay, we'll get into things in the coming weeks like pile caps, which I'm sure everybody knows something of, but we'll get into them. We'll get into pile caps, we'll get into embeds, we'll get into steel framings and point loads and all these things. We'll get into shear walls, we'll get into frangible walls. This is not something you can cover in one class, okay? So this is merely the introduction on how you start getting the house out of the ground. Take this stuff, look at it, make sure you understand it, because next week we're going to go through a slight review of this, and then we're going to work up the house. Okay, we're going to go through things like here, you might not see it on there, but these triangles are pile caps. Okay, pile caps are made to point load. We talked about point load. Pile caps are made to hold a point load, which exceeds the strength of one pile. Okay, we'll go through all that, but I really need you to take this stuff home. A lot of you guys, I really appreciate, have gotten back to me. Jason sent me a text message this week on things he'd like to cover. I think that was great, okay, and I really appreciate that. You guys, if I'm going too slow or too fast, let me know, okay, but I gotta take this one step at a time or you'll get lost. If there's something we spoke about this week you don't understand, let me know, because we're getting into things that are going to get more complicated. Everything up to this point has been pretty straightforward and easy to see. Now we're going to go into things that are going to be a lot harder to understand because they're all conceptual. They're not all something you can visually see like a grate. Okay? We got anything? All right? Sir?
Learn this word like stirrups for inspection, depending on your inspector. Superintendent, you better make sure you got the spacing right because I found it right away.
There's a lot of things the inspector's going to look at. He's going to look at making sure if you have a conduit running across the top of a form, that the spacing between them is 6 inches. He's going to look at a lot of things that you may not think of. You need to rely on your electrician to make sure he knows the codes that aren't drawn. Excuse me. The codes and things like that aren't on your drawings. That's up to your subs to know. So you have to go through this stuff and make sure you're right. As a rule, the shell contractors who have been doing this are pretty much aware of what's needed, but you need to walk through and make sure what you're looking at makes sense. Okay? All right, guys, let's wrap it up. Go to a meeting.
Thank you, Joe.